Good morning, fifth graders. I keep saying good morning. It's probably could be afternoon. I think the kids at school, you guys do math in the afternoon. So good morning to all of you and good afternoon. Tie Tuesday, so hopefully you're all looking dapper and feeling good today. I want to start math by emphasizing that the theme for the day, for the week, excuse me, that says math week 31. Look at the little Bitmoji saying you guys are smart. And look at the theme. Read that theme right there. I know it all. Yesterday was kind of officially and unofficially our last day of learning new math. Now, there might be some math that I sprinkle in there that you haven't seen yet, but mostly, congratulations, you've learned all the fifth grade math you're going to learn. Now, it's somewhere in your brain. We just got to unlock it all. You got to remember it all. And then you have to be able to apply it to word problems. What? Don't worry. We'll get you all set to go. So really the next 2 to 3 weeks, probably the next 3 weeks, is really about that. It's about having a lot of mixed review, different kinds of problems from all parts of the year, and then trying to remember how to do those, dig back in your notes and in your mind, and then go back and try to do them. And that's what our blue sheet is about. That one blue sheet, this, your packet, okay? And daily, really what the main heart of the lesson is going to be is a little bit of notes here and there, but a lot of working on the things that came in your packet. Okay, so sheets like this, and then from there, taking those sheets and really taking your time to take a little bit of notes on them and to do them, and then your homework each night is going to be something that looks almost exactly or very similar to this, the same types of problems. So you'll have them in this form, and then when you go to do it at night, you're going to have to do it in your notebook, and then you'll be able to try the same problems, and that'll kind of unlock it from your mind. Okay, so it's kind of like we do, and then you do, meaning we're going to do it as in the videos, or you're going to be doing it with your teacher, and then you do, meaning now after that you need to try them on your own. Because as you watch the teacher do it, or you're doing it with me, you're going to be like, oh, yeah, I remember how to do that. It seems easy. But then you have to do one on your own. Then also, because it's so important, we're going to be correcting the homework every day. So the homework is not due in 2 days or 3 days. It's really important that you do it each night. I don't ever give you more than 8 problems to do. And then those are the basis for the next day's lesson. We're going to then correct that. And then you can see, oh, I still don't know how to do this one. Or, hey, I do know how to do this one. So that's basically the plan, okay? All right, so let's start today with a problem of the day, okay, based on what you did last night. So this is a great time there's actually 3 problems of the day. So you might want to get out your notebook right now, pause the video or grab your notebook. And then there's 3 problems. You don't need to write all of these out. Let's just think and talk about them. So we have how many inches is in 1 foot? How many inches it then would be in 3 feet? And then the most challenging one, how many inches would be in 3 1/4 feet? So I'm going to switch over to the other screen and do these really quickly with you. So it's a good time to just talk about them. You could do them in class and fast forward this part of the video, or you could just try them on your own and then unveil. Okay, at home also. All right. Don't need to pause. I'll just switch over. Okay. So the first one we had is how many inches are in a foot? Yep, you guys just said it out loud, or at least you said it in your mind. You tried to not even say it and you knew it. So there are 12 inches, 1 foot equals 12 inches. So 3 feet would equal how many? Well, if there's 12 in 1, then it would be 12 in 1, another 12, and another 12, right? Which is 36 inches. Or you could remember, if you have repeated adding, of course, that's multiplying. So 12 times 3 is 36 inches. Just 2 ways to do. How many inches are in 3 feet? 12, 12, and 12. Okay, but this last one's a little bit more challenging. How many are in 3 1/4 feet? How many inches? Well, you already know in 3 feet there's 36, because we just did it, right? So that's gone. But now you have 1/4 of 12. I'm going to repeat that. You've heard this before, 2 chapters ago. Let me say it again. 1/4 of 12. Super important right now. Let's emphasize. Someone out there, tell your teacher, yell it out loud to the universe. What does of mean? It's an operation, adding, subtracting, multiplying, or dividing. What's of? Of means, that's right, almost always multiply. I'm going to make a little division sign, sometimes divide, but usually multiply. If you're taking a part of something, especially a fraction, you're multiplying it, okay? So that means we have to do 1/4 of 12. Now you might be asking, why am I doing 12? Because there's 12 inches in a foot. And the question was, what is 1/4 of 12? So do you guys remember how to do this problem? See, this is what I'm talking about. The math is becoming mixed. Mixed as in, you have to remember all of this. This was 2 chapters ago. What do you do here? Oh yeah, that's repeated adding. Or we put it over 1 and we multiply straight across. 1 times 12 is 12. 4 times 1 is 4. You get 12/4. Wait, got to remember this too. Well, another thing for you to write. Take this in your notes. All fractions are what? Hopefully someone out there in your mind, now it clicks in my mind because I'm the teacher, I've taught this so many times, but it says all fractions are, remember Gilroy would tell us, division problems. But problems spelling problems. Okay, so if all fractions are division problems, then 12 divided by 4 equals what? Yeah, 3. So what's 1/4 of 12? 3 inches. So there's the 1/4 part. So then 36 plus 3 is 39 inches. So let's repeat that. How many inches are in 3 1/4 feet? Well, in 3 feet, there's 36, right? 12 plus 12 plus 12. How many are in 1/4? What is 1/4 of 12? 1/4 of 12 is 3. So 36 plus 3 is 39. There's some math for you right there. Okay, before we correct the homework, let's correct the homework next. So get out your homework. This is what you're going to want to, or your classwork, or however you do it in class. This is where we're going to correct this, and you're going to want to break it out. Now, teachers, Miss Lindsay and Miss Smith, if you just want to do it in class with them, and again, fast forward with me, or I'll do it however you want to do it, that's fine. Kids at home, follow along. Now, that means you would have had to do your work. All right, so here it is, really quick. So let me go to draw. All right, first one, how many inches are in 1 foot? That's right, 12. How many weeks are in a year? This is the one that I put on here because I don't think a lot of kids know this one. Okay, you know how many months are in a year? 12. But how many weeks are in a year? 52. How many meters in a kilo? Here's what matters. Kilo. Do you remember what kilo means? Kilo means 1,000. Sorry, horrible. I'm drawing with the mouse. 1,000 meters. How many feet are in a mile? This is the random one. Totally random. Just got to memorize it. 5,280 feet. How many ounces in a pound? 16. Here, there's another prefix. Centi. Remember century? Like 100 years. Centipede, 100 legs. What's centi mean? 100. So how many centimeters are in a meter? 100. I just lost my mouse. There it is. 100. Okay, now I think this part it was literally in your notes. So if you took notes yesterday, you could have just copied it. Okay? But down here, you had to do a little thinking. So how many inches are in 4 feet? Well, remember, there's 12 in 1 foot. So it'd be 12 plus 12 plus 12 plus 12, or 12 times 4, right? Because there's 4 of them to get 48. Now, some of your brains, it just kicked in and you just knew it's 48 inches. Okay, how many inches in 4.5 feet? Well, we already have the 4 feet, which is 48. And then what's half of 12? Half of 12 is 6. So add another 6 to get 54. There it is, inches. Okay. How many meters in 6 kilometers? Remember, kilo means 1,000. So it's just 6 times 1,000, which is 6,000. Now this last one, I love this last one because it's going to bring us back to stuff we've already learned this year. How many centimeters are in 4.8 meters? Centi means 100. So we have to multiply this by 100. And you're like, oh, Mr. Mannerfeld, I got to go like this and do magic zero and all this, right? No, you do not. Because fifth graders, remember, this is a 2-second problem. You're like, 2 seconds? Yeah, if you multiply by 10, 100, or 1,000, you just move the decimal. How many times we do move the decimal? Let's count how many decimals there are. Oh, I wanted to switch colors and be dramatic. 1, 2. So just move the decimal 2 times. 1, 2. What goes here? Remember, what do we fill it with? Yes, a 0. So guess what? 4.8 changes to 480. So how many centimeters are in 4.8 meters? 480 centimeters. So there is your homework. Next thing I need you to break out, fifth graders, I need you to break out your packet. We are going to go over and do a little activity with our first page of our blue sheet. So let me X out of that. Okay, you guys can see me again. All right. Oops, I should have left that up. All right, so now that you have this out, or pause to get it out. Another part of your homework last night was to study this. Now, I know kids aren't going to study it. You're just going to be like, I didn't even look at it since last night. I realize that that's life. But if you want to do well on the California State test, and I want you to because you are smart kids, and I want you guys to like blow it out of the water and say, yeah, we missed a year of being in school, but it doesn't matter. We have great teachers, and we're smart kids because you are. You got to just remember this stuff, okay? So just a lot of just remembering now, and if you take a few minutes to study, you guys will remember stuff, okay? So let's go through these quickly. And then formula for volume. Remember, length times width times height, or bottom layer times how many layers there are, base times height. How many inches in 3.5 feet? Well, now at least you guys get this. How many inches are in 1 foot? 12. And you don't even have to do the math part. Just say 12 inches in a foot. How many ounces in a pound? 16. Now, can you figure out this actual answer? Yes, but that's not what the flashcards are for today, at least. How many meters are in a kilometer? Yesterday, you didn't know. Remember what kilo is? This is the third time you've heard it now. 1,000. Centi, century, centipede, 100. Alex has 4 friends. They share 2 pizzas. How much does each friend get? Oh, can't trick me. It's not 4 over 2. It's stuff over people. How much stuff? 2 pizzas over 4. Nice. Guys are on fire. How about this one? There's 1, 2, 3, 4 operations in one problem. How do you do it? Oh, yeah. Please excuse my dear Aunt Sally. Parentheses. Exponents, which there are none. Remember, exponents is a little number that goes up there. Multiply and divide would win, and then adding and subtracting, but subtracting comes first in the problem, so it'd be subtract then add. Remember, you'd pull down. We'll work on that when we get to it. Prime factorization. I forgot what prime factors are. That's the factor tree. Remember, you start the tree and circle them. And then finally, how do you move on a coordinate grid? You always go over and then up, over and then up. So teachers, if you're at home, kids at home, just study this. Like, just look at it. Remember, the answers are on the back. The way I did the routine, Miss Lindsay and Miss Smith in class, is I would do 4 steps, okay? I would first do a minute. I'd actually set the timer and give them a minute to just study it in their mind. Then I do a minute, partner 1 asking partner 2. Okay, so just random, not even in order, just pointing at different stuff and quizzing them. And then we'd switch, and partner 2 would ask partner 1, same stuff, mix it up. And then I would do it as a whole class. So I'd get some incentive like candy. I don't know if you can even give out, it's COVID. I don't know if we can give out stuff or not. Or stickers, or just points, or I'd just ask kids to use the smartest. And I put this, I display this, and then I just quickly go, what's this one? What's this one? What's this one? What's this one? You know, and we go through it. So please study this. All right, now what we'd have to do is find this. Now you have this whole packet. Miss Lindsay did such a great job yesterday organizing her whole packet. You guys have to find the math page that looks like this. Now the only thing that really distinguishes it has a little page 12 on the bottom. So can you guys find this, please? Okay, I'm assuming you have it, and we're going to do it. So this is going to be classwork. And then you are going to have a page that looks a lot like this, a paper that looks a lot like this, almost the same kinds of problems for you guys to try for tonight's homework, okay? All right, so let's take a look at this first one. Now, you see how this is mixed review? This is all different kind of problems of stuff we've done this year. So the first one here, what kind of problem is this? Repeated adding or put it over 1. We already saw these today. And multiply straight across. Here's the thing with multiple choice, 5th graders. Let me grab a sticky note. Multiple choice tests, math tests, are actually pretty easy. These answers are all there to mess you up. Okay? So don't even look at them. We don't care. We don't need no stinking answers. We're going to do the math on our own. Okay? So 12 times 1, straight across. 12 times 1 is 12. We already did this problem today. 1 times 3 is 3. 12, remember all fraction division problems, 12 divided by 3 equals 4. So I did the work on my proof paper. I know the answer is 4. Then I can look. Anybody see it? Yes, of course. There it is. Easy. Okay. Question number 2. Enter the area in square inches of the rectangle. Area, what? Okay, go dig in your brain. Area, what is the formula for area? And I know somebody out there said length times width times height. No, that's volume. Think of area, Miss Graham. Oh yeah, length times width. So what do I have to do to the two sides? Multiply them. So all you have to do is 7/8 times 3/4. Now, I want you to write something over here in the margin. What kind of problem is this? I'm going to put a star by this because we're not going to keep writing this, but this is the question you always should ask yourself. What kind of problem is this? That's what these flashcards are about. Eventually, almost all the stuff we learned is in this packet. And you got to just memorize what kind of problem is it. Because if you know what kind of problem is, you're going to remember what to do. What is it? Oh, yeah, multiply straight across. So the answer is 21 over 32. And you're done. That's it. All done. All right, let's go to the next one. What positive value for B makes the statement true? Now, this gets me very confused. This is a double star problem, 5th graders. I guarantee this will be on the state test. Okay, so pay attention to this problem. This is like a super important one. It says, what positive value for B makes the statement true? Now, when I see that, I get confused. I'm like, what? There's a letter and true, and I don't want to even do it. But it's not a hard problem. Look, 6 times what, so something, is going to be less than 12 but greater than 6. So what could make, if you multiplied 6 by one of the choices, we're going to do one at a time, will make the answer bigger or less than 12 but bigger than 6? Well, what happens when you multiply by a fraction? When you multiply by a fraction, please write this, multiply by a fraction, what happens? When you multiply by a fraction, come on, we memorize this. When you multiply by a fraction, the number gets bigger or smaller? Gets smaller, because you're taking a part of it. So if you multiply 6 by half, the answer is going to be smaller than 6. They want it to be greater than 6. Plus, what's half of 6? You can think of that as 3. Is 3 bigger than 6? No. So whenever you multiply a number by a fraction, it's going to get smaller. They want it to be bigger. So no. How about 1? 6 times 1 equals 6. So you're like, yep, that's it. Nope. Greater than 6. Oh, that didn't work. right? Because 6 times 1 is 6. They want a number that's greater than 6. Look at this one. I'm going to skip to D for a second. If you did 6 times 2, what would you get? 12, right? 6 times 2 is 12. And that they want it less than 12, so it can't be that one. So it's this one. 6, it's the mixed number, because let's do the problem quick. 6 times 1.5, right? Because they want you to do 6 times 1.5. How do you do that kind of problem? What kind of problem is this? 2-box area model. See, you forgot. But you did know that. Your brain should just went, oh yeah, Mr. Merrifield, I know. So 2-box area model. 1 1/2 up here. Where did I get that from? Right there. Times 6. It's going to be very easy. Watch how quick. 6 times 1 is 6. 6 times 1/2 is repeated adding. Or put it over 1. You get 6 over 2. All fraction or division problems. 6 divided by 2 is 3. What do you do to the numbers inside? Add them. 6 plus 3 is 9. So your answer would be 9. Is 9 greater than 6? Yep. Is 9 less than 12? Yep. So that's why it is this one. All right, let's take a look at let's just do one more. I have like this mental sense of when enough is enough, and you guys have really been sticking with it. We could do these other ones later. Let's just go to one more. Micah has 6 cans of soda. Each can, huge keyword, you guys, means multiply, and look at, I'm going to put a little, sometimes divide, but almost always multiply. So every one of the cans is 11 2/3 ounces. How many ounces does he have? So again, they're telling you what to do. 6 times 11 2/3. What kind of problem is this? What kind of problem is that? How do you do that? You guys already know. We just did it. It's 2-box area model. Whoops. Again, do I care about these answers? Nope, they're there to mess me up. So I'm not even looking at them. I can do this myself. 11 2/3, right? We split it. 6 on the side. 11 times 6 is 66. Right? What meets in this box? 6 is coming over. 2/3 is coming down. Put it over 1. Multiply straight across. I know I'm going a little fast. But you get 12/3. All fractions are division problems. 12 divided by 3 is 4. What do you do to these two numbers? Add them. What's 66 plus 4? 70. So look, I saw this problem. I knew that each meant multiply. So really, this was secretly, even though it's on a word problem, it said 6 times 11 2/3. Then I had asked myself, what kind of problem is that again? I forgot how to do those. Oh yeah, 2-box area model. Go ahead and do the math. You get 70. See, I'm not going to look at their answers now. I'll see. Boom, there it is. And that always feels good when it's there. All right. So your homework tonight is going to be basically only 5 problems. There'll be 4 like this, very similar to these. And then I'm going to add 1 more from last night's, like what we learned last night. And that's it. Actually, I think what I'm going to add, I take that back. The 5th problem is going to be a please excuse my dear Aunt Sally problem. Okay, how do I get out of this? Let's see. X this out. I think, there I am. I'm back. So, hey, don't get stressed. You guys will get used to this new routine. And remember, you know it all. It's somewhere in your brain. All right? So please, please, please do your work. That's the most important part. If you don't even practice your work tonight, practice problems like this on your own. If you don't even do that, then you're never practicing the math. And of course, you can't remember and get better at it because you're not practicing. So please do your work. It's 5 problems. Thank you.